Hello everyone, welcome to Prime Number. In previous episode, we talked about the transaction in very detailed explanation. But that transaction is in V1 and that is paid to the public key hash transaction. Today, I'd like to talk about the segregated witness transaction. Bitcoin was criticized by its performance, and there were several proposals to increase the capacity of the Bitcoin network, such as increase the block size, but this one required a hard fork, which creates another coin. The BCH, for example, is doing this approach. And the other approach is to separate some information in the block which is not really needed to put in the history. Well, it's needed to validate the block, but it may not need it to keep in the history, such as the signature. So SegWit is to introduce another structure similar to the transaction structure, which is also a Merkle tree. They separate all the signature into a separate field called witness and combine them into a Merkle tree and put the hash root into metadata of the block. Since it removes the signature from the block, it will reduce the size used by the block. Well, the data is still in the block, but it's not calculated when you calculate the block size. So the segregated witness also introduced a weight unit, which replaced the size via doing 1 byte will equal to 4 weight unit if it's non-segregated transaction. But if it is segregated transaction, so 1 byte will equal to 1 weight unit. By doing that, you can see if it's segregated transaction, the transaction fee will be dramatically reduced, and the capacity of the block is more than 4 times bigger than non-segregated transaction. There's also another benefit to separate the signature from the block. The reason is that the transaction ID is calculated by the hash of the transaction. But since the ECDSA signature has, based on its algorithm, it's possible you change the signature, but it's still a valid signature. But if you included it into how you calculate the hash to come up with the transaction ID, then the transaction ID will be a different one. That causing a lot of problem. For example, if you want to withdraw money from an exchange, the exchange is always using the transaction ID to track whether you successfully withdraw your coins. Since the transaction ID can be changed by the malicious miners, the exchange will not be able to track the status of the transaction. That can causing a double spend if you request the exchange to pay you the coin, but actually you already receive it. So don't get confused that even though you can change the signature of a transaction, but you cannot change from, to, or anything that you signed. So you cannot change the body, for example, to pay the coin to yourself instead of the one is supposed to be paid. You only can change the signature that will come up with a different transaction ID. The segregated witness address is different from the traditional or legacy Bitcoin addresses. There are two formats of the Bitcoin, of the segregated address. One starting with letter 3, which is similar to multisig addresses. It wrapped the segregated witness into the pay2 script hash. The other format is called batch 32 format. It's encoded using batch 32 format. So this kind of address starting with letter BC1. The segregated address starting with 3 is compatible with all the legacy wallet. So you can still using any wallet to send to segregated witness address, even though it's starting with BC1. The batch 32 format is the segregated witness native format. We will take a look how the P2SH format as well as the batch 32 format works to support the segregated witness transactions. Let's see some real examples about the two different formats of the SegWit Bitcoin address and how it was executed. So first of all, let's take a look at so what is the witness parameter. So I randomly pick up one of the transaction today, and you can see here in the input there is the script sig is empty, and there's a parameter called witness, and it has two items. One is this is the signature, and this is the public key. So this input reference to this one, it's 37 AF. Yes, reference to this transaction index 1. So let's take a look at this output index 1. Here you can see the type is witness v0 key hash, and the script public key field is by BIP 141 definition should be just 0 and the witness address hash. So we can take a look at BIP 141, and the transaction we just saw is this one, pay2 witness public key hash. So in the script public key, the format is 0 and this 20-byte key hash, and this is the output. And in the input, and this is the output in previous transaction, and the input witness is only a signature and public key, and the script sig is empty. So how it works is that the Bitcoin, the miners or all the consensus algorithm will actually implicitly convert this script public key to same as the pay2 public key hash. So it will do the op duplicate, it will do hash 160, it will compare the public key hash and verify, and also check the signature. So that's implicitly verified. So this is we call native segregated witness. And the other kind of witness is, I put another example here, is okay, this is a transaction, and this similar, it's referencing to previous output 1, and this is the signature, this is the public key. So the difference is, you can see here, this is script sig, this is not empty anymore. And if we take a look at the previous transaction, 2BE4, and the output index 1, you can see. So this address starting with 3, if you notice, the previous address should be starting with BC1, that is the native SegWit address. So this is the P2SH hash, P2SH address starting with 3, and the script pub key would be a standard P2SH, and it's the receiver who take charge of how you're gonna redeem this Bitcoin by providing a script, and the script has to be exact match the hash of this hash check. You can see that you do a hash and it has to be equal. So let's also take a look at this type of transaction in BIP 141. Okay, so this is pay to witness public key hash nested in BIP 16, that's pay to SH. So here you can see the script public key will be just do a hash 160 and the 20 byte script hash and equal operation. And in the witness is the same signature and public key. And the script sig is 0 and it's this 20 byte key hash. That covers most of the Bitcoin transaction related topics. I will talk about the Bitcoin blocks, how that works. But there are still a lot of pieces regarding Bitcoin transaction. Maybe I will come up with some small videos to talk about them in the future. Thanks for watching. Comments below what you like to see in my channel and subscribe if you like it. Thank you.